the latest version of OBS. It's telling me that everything is a-okay, so I hope it is. So hello to who have we got here? We've got Standard In and we've got Magetsub so far. That's not bad, given that I don't sort of advertise any of these things. You guys must live on the Discord server, right? Well, I'm not going to have like a big massive introduction or anything. We're just going to get stuck straight into it. I'm going to be working with the audio PGEX that we started work last time, and hopefully get a bit more code done, because after the last CodeZone, I went ahead and started to sort of implement things a little bit, at least some sort of a bit of an interface, because it was all sort of undecided, undefined. And oh no, just notifications on content creators. That's good. So basically, you've watched every single one of Solly's streams for the last 6 months, then. Right. So what I've intended to do now, this is where people are going to get a bit excited, because I'm putting hash if defines in various places of code, and there's usually a better way to do things than that. So the plan is the following. I will zoom out just a tad for a bit more screen. We know that we're creating a extension called the Soundwave, which the idea is to sort of be a bit of a tidy, more modern version of the original sound PGEX. And hopefully today we'll get to the point where we're at least making some sounds. But what I wanted to do was abstract away the sound interfaces. So we had back ends for ALSA, or ASLA, whichever it is. We had OpenAL. I had the Win multimedia library. Magetsub contributed an X Audio one. I also have a Wasapi one, which is, I think, worth throwing in. And I'd like to get an SDL mixer one, so people can use the Sound PGEX with Emscripten with no fuss. So that's the plan. Gromit, hello. And Josh Undefined, you are undefined. Hello to you. Let me just put the right chat on in the Discord server, because I don't know where people chat. People typically don't chat on Discord during this, but I like to have the CodeZone window open just in case. And if you didn't know, a video has gone out. I know that's an original idea, isn't it? I put a video out at the weekend about fixed point numbers. It's on the main channel. If you've if you've seen it, then what do you think? Let me know what you think. Doorbell Prod, MFWOLC, MFW. I'm no good at these things. I'm going to have to look what that means. Good to remember. I'm technically, my face went OLC. Oh, excellent. Well, it could have been a lot worse, I suppose. And Standard In volunteering to do an SDL mixer one. Oh, that would be appreciated. I'm becoming more accepting of the fact that if I want the Pixel Game Engine project to sort of progress, I've got to open it up a little bit more. I simply haven't got the time anymore to modify everything myself. And I've been relying on a few robust hands on the Discord server. So Magetsub has a big role in Pixel Gaming, Slavka does, Dandestein does. These names on the Discord, but I think it's time to open the doors a bit and let a few more people do some contributions. So yeah, any sort of voluntary action like that, I'm more than happy to put there with full credit, links to your own GitHubs, and I think that should be worth something, because the One Encoder GitHub does get quite a bit of traffic. Anyway, that aside, hello to everybody that's joined since, and I apologise for my quite blatant boomerism. I'm not familiar. Somebody on the latest video, I had a bunch of comments which said Giga Chad, and I didn't understand that at all. So I had to rather embarrassingly go and ask people on the Discord server what is a Giga Chad. At which point they just assumed I was old and worthless and meaningless. Thank you, Max CE. First time chat from you, Max. That's interesting. Excuse me, I'm going to have a slurpful of tea. So yes, you may have noticed CodeZones. I can't sort of stick to a regular schedule anymore. It was meant to be last night. I wasn't very well with this cold. You might sound a bit like Barry White today. Oh yeah. Can't get enough of your love, baby. But the reason it's sort of not fixed anymore is usually it would have been 8 o'clock, and then I thought 8:30, and now it's going to be 9:15. But it's going to be the right duration, and we're going to get on with it. So it would be nice for once in a CodeZone to actually write some code. So let's see if we can get on with it. So the idea was we're going to present this sound wave class, which is really just a big singleton, because that's how we expect the user to interact with the PGEX. Now that might change again a little bit towards the end of this project. And we defined some basic functions. So one to initialize the audio, and setting the callbacks. I've made these a little bit more explicit in name now, because there's some properties I still quite liked, and we didn't really decide what a waveform should be. So the what I wanted to do though was sort of all of the mechanics of the sound I wanted to throw out somewhere else. So I created this interface called an audio driver. Now, this audio driver was an abstract class, and then I decided, actually, do you know what? I don't like it being abstract. And it's got some fairly dodgy pointer stuff going on. Again, all of that will be tidied up. Let's make it work first. And the idea of the audio driver is, what I noticed was there was a lot of commonality between the backends. They use the same data structures, the same properties, that sort of thing. So it makes sense to sort of encapsulate it. And then the plan is that we go and implement then specific audio driver mechanics. And so, for example, I was going to start working on the Windows Multimedia one, and there's no code in it yet, but the idea is it goes away, and the driver needs to implement some properties. So this Soundwave object here is actually the user interface, for want of a better phrase, and then later on we actually need to go and enter some properties. And so there's lots of ideas. It's still not crystallized yet what's going to happen. And I had this sort of plan that obviously the audio driver will have its own thread, and we're going to be gratuitously copying and pasting code from the existing sound PGEX. And I quite like the idea of the driver then calling the interface up here to populate with X samples. Populate a structure with X samples. And it goes away and does it. So that's why I've got this sort of function, fill this buffer please. Now that's going to change, obviously. It's just me sort of thinking through code. So that's kind of the plan, and I think what we need to do is study the sound PGEX original to look at the Windows Multimedia layer implementation, because I just cannot remember it, and this is it here. There's not much to it really. And I think we're going to have some fun and games with static stuff later on, and probably audio static stuff as well. So the idea of the sound sort of engine, as with all of these engines, is you prepare some memory, and the sound card requests some memory from you periodically, and it says, please fill this memory with samples. And so that's really what we're relaying to the user. We're just tidying it up a bit because I want my samples to be in floating point rather than some sort of thing. What's this? You should add better TTV for this Twitch channel so those with custom emote strings won't look goofy without context. Wow, that's like totally not anything I understand. Right, okay, better TTV. Emote strings won't look goofy without context. Is there a custom emote string somewhere? I can't see it. Better Twitch TV. Oh, it's making me sound old. So I think we've obviously got to open and close the device, and we need to know where we're going to do that. So let's do a little bit of work on the sort of the user interface side of it now. Now the plan was the constructor is it's a static object, like I say, it's a singleton, so it's going to sort of just happen. And at that point we're going to choose which of our backends to use. Now this has to be done with sort of this pre-processor magic, because you've got to choose depending on the operating system and all that other good stuff. But we also need to expose a way of making this selectable to the end user as well. Again, that's some cosmetic things we can finish. But it will load up a driver, so I can imagine we'll have a variety of different drivers being implemented with a variety of different sort of interfaces. So Wasapi is another one that I want to work on, and that will load up the Wasapi implementation. See? And the Pixel Game Engine actually uses this pattern quite a bit to load its various core components. Almighty David 2004, you're happy that I'm uploading again? Oh, well, thank you very much. It's not going to be quite as frequently, but I am going to be aiming for every month at least. We've certainly got enough topics to talk about. We did mention it in the last CodeZone, so these are all ready to go to make videos about, so I'll worry about that at some point. Morris, oh, hello Morris. Howdy doodly. Yes, indeed. Oh, good. Morris is here. So Morris is also quite a significant contributor to Pixel Game Engine stuff too. When I was listing them out before, I didn't actually mention Morris. Mainly because he implements stuff and then bitches about it that I don't include it. So you've just recently implemented a show cursor function, which is probably the most popular request about something to add to Pixel Game Engine. Right. Where are we going to do? So we've got this function called initialize audio. Now I'm going to assume that all of the audio driver implementations are going to need this sort of information. It is sort of the common theme across all of them. It's the sample rate that the system is going to operate at, the number of channels, is it mono, stereo, 5.1, 7.1, and then 2 additional parameters. Now, we may change these later on into something a little bit more generic, so you can pass through some information. But from what I've seen, all of the implementations rely on a similar idea of you have this circular loop of memory blocks. In fact, you know what? I'm going to get the old OneNote out. Hang on, let me just move my cheesecake. It is invisible cheesecake because it's been devoured. Let me just also move my circuit synthesizer. There we are. Getting a bit crowded up here. And let's ping OneNote. Let's get that going. Yes, blind us. Exactly, right. Here we go. So everybody, and it'll have, oh no, it's come up on the other window. That's a shame. Oh, well, I'll drag it onto here. So there we go. Right, everybody who's using the screen for illumination, you can see what you're doing now. Right, so what happens then on a sound card? So let's sort of flesh this out a little bit. I've got to choose carefully where to draw on here because of all the additional bits and pieces on the screen. So basically the sound hardware, and we'll call that, for now we'll call that the DAC. Digital to analog converters. This is occasionally, once this gets going, this sort of sits attached to the operating system, and it's the operating system's job to feed this with data whenever it needs it, and the operating system will then call my program for information. And it does this sort of periodically, and it does it by requesting a certain block of memory. Now, if we just had one block of memory, I would sort of, my program, let's put my program up here. So that's my program up here. It says, please fill this block of memory. I go and fill it, but whilst I'm filling it, the OS has nothing to do. So typically you need 2 blocks of memory, like this. So whilst I'm filling one of them, the operating system is emptying one of them out, and it's emptying them out into the sound card. 2 doesn't tend to work very well either, because your OS tends to run well at a different speed to your program. So what you end up doing is specifying a whole circle of these memory blocks like this. And each block is of a fixed size, and you just keep pushing the data around. This program writes the data, and then the operating system consumes it when it's ready. Now, this will be really steady because it's a sound sample. It's important that this is just happening at the right rate. If it doesn't, you tend to pick up on it. You'll hear glitches and pops and things. But my program won't be running at any sort of consistent rate at all. There's all sorts going on. That's because my program branches unpredictably, probably. So it's quite useful then to have all of these buffers. So you've got a nice buffer of data lined up, ready to go, to make sure that the sound going out to the sound card is nice and consistent. But this introduces a problem. If I've got, say, 10 milliseconds worth of sound there, and 10 milliseconds here, and 10 here, and 10 here, and 10 here, and so forth, I've got 1, 2, 3, 4, 5, 6. I've got 60 milliseconds worth of latency. So my program, if I press a key in my program, That's a key. It's a squiggle. If I press this in my program, then I start to create these samples. I start to put them into these memory blocks, but we don't hear them until 60 milliseconds later. Now that's pretty poor, actually, 60 milliseconds. Really, you want to be down into single digits milliseconds, particularly for live sort of performance and responses. We'll have a quick glance at the chat. Max has just been accepted in a different school. I assume that's worthy of small celebratory drink. Yeah, okay, good. Sensible people would call that a queue. Yeah, but do any of us look sensible here? I mean, let's be honest, the audience are clearly not sensible. They've got nothing better to do on their evenings other than watch me bungle through code and drink tea, so that's not exactly sensible. And I'm certainly not sensible, because I'm rewriting code that I wrote 4 years ago and I've forgotten how to do it. Oh, there's something interesting in one of the videos, and I need to investigate it. So we're getting distracted already. The most recent video was on fixed point numbers, and there was a great comment. Let me see if I can find this. Pull it up. YouTube. And I said I'll go and investigate it, but I'm unsure yet. So we'll have a. We'll see what's going on. Oh, right. Let me just stop me from saying things. If I bring this in. Right, so the comment. Let's find it. Find it. Where is it? It wasn't a small one. Oh, why can't I find it now? Ah, there we go. From Thomas. Let's zoom in a little bit. Oh, we've got into YouTube mobile mode now, haven't we? That's disgusting. Right, so what was it? Thomas. Right. At this particular time, your circle circumference is 35 and a bit. And it was about 35.11 or something like that. In 4.4 format. But in 4 bits, you cannot represent 35. Is the compiler cheating and using a bigger type during const expression evaluation? Now, I've not done any investigation into this yet. I've not even looked at the timestamp on the video to see if the code is accurate. But I thought it was pretty insightful, and if it's accurate, this comment, it certainly would be an interesting investigation to what's going on. Fundamentally, what he's saying is, because I'm using 4 bits and signed bits at that, how am I possibly representing 35? And so I think that's worth investigation. Chances are, I don't think const expression is wrong. I don't think it's evaluating things. It's more likely I have said something in the video and done something else. But I've not done the investigation. But certainly, after this stream, I'm going to have a look at that. And it'd be really cool if we did find something wrong with const expression. But I suspect we're going to find something wrong with Javid expression instead. So, worth looking at if any of you are interested in fixed point number arithmetic. Rewriting old code always hurts. Do you see things you did wrong? Yeah, well, I have no objection to rewriting old code. Oh, hang on, we've jumped on quite a few here. Yeah, writing the cursor stuff. Obviously, Morris, you're privy to sort of Pixel Game Engine 3 development stuff, so you'll know that will actually be one of the features going into Pixel Game Engine 3. So we'll steal your code, and I'll just take credit for it. And people will think, wow, that Javidi implemented a really good idea there. Anyway, that's what these blocks and sizes are in the sound card implementation. So that's why we specify this. Controlling these things has a direct impact on latency, and if you have too little latency, you'll end up with starvation of the sound hardware. It'll pop and stutter, and if you've got too much latency, things will sound great. There'll be no problem at all, but if you press the key, you'll physically have to wait. And if you're a guitarist or a sort of a synth player, something where you're quickly doing things with keys, I can't play if there's any delay after about 20 milliseconds. My brain just goes, whoa, hang on, and my fingers start getting in sync with the delay, and it becomes a horrible mess. No, of course, everybody that contributes. With Wasapi, you can basically discard all of that. That's not quite right. There's still there's still sort of a rotary buffer of things. Is the fixed point stuff on the GitHub yet? No, it isn't. I wasn't intending to put it on the GitHub. I was going to just sort of make it available on Discord if people want it. Okay, I'll put it on the GitHub after this. Yeah, probably if it's worth investigating, then I'll make it available somewhere. In fact, where can I? Let me just go and grab it. So if I go to, I knew this would happen. I'd start talking about this instead of doing sound stuff. I think it's a me error. It's not a not a problem with constant expression. So fundamentally, here we go. So we create this 4.4 type, which uses this 8-bit integer as its fundamental type, and everything seems to check out. And when you go to the end result, it's managed to convert that to 35.125. And so there's something fishy going on there, and I suspect what's happening is the casting here. This casting. We go to double. I think this is getting promoted. See, even that doesn't entirely make sense. It's almost as if everything ended up sort of being a larger type. It's a strange one. Where can I bang this code? Can I drag from Visual Studio into Discord? Well, you see, I just feel that constant expression shouldn't do integer promotion, because then what's it reliably doing at compile time? Is it behaving differently to runtime? Oh, I can just drop this straight into Discord. Well, at least it gave me the illusion I could drop it straight into Discord. It lies. It gave me the cursor of lies. Hang on, I'll have to pop a window up and go and find this. Fixed point numbers. E drive. PGE vids, this one was. PG vids. Fixed points, there we go. Right, so I've just dropped that into the CodeZone chat on the Discord. So that's exactly this file here. Okay. So it's possibly integer promotion that's causing that problem. But I don't like it if it is. If that's not a nice precedent to set, that means this constant expression thing is well, it cheats. And therefore, I don't trust it. It made the actual. It's not something I'm going to get used to doing in videos anyway, because actually zooming in all the time to get these tooltips was a real nightmare in the edit. But I just wanted to. I thought it was interesting for. I know a lot of people watch the video and they've never sort of seen constant expression in any of my videos before, and certainly not the creating your own literal suffixes either. Just too little. I like to throw in something that most people won't have seen in a video. What is the point of constant expression? It is a function that can be evaluated in its entirety at compile time. So, for example, I don't know if you watched my fixed point video yet, Morris. Here I'm creating a type, and I have my 5.6 value here. I'm converting it to a different numerical format, and I'm doing that at compile time. So I can actually see it goes away and populates these variables. So in this case, this calculation circ I don't know if you can see on the stream, but if we zoom in, it's actually calculated the result here. Based on my classes and doing all of this stuff, it's all happened at compile time rather than runtime. Don't need to do sort of compile it each time. I think it's a bit overrated, and I'll go on my usual sort of one lone coder CodeZone rant here. In my opinion, C++ compilers have been doing const expression evaluation for, well, about 20 years, and the only difference is now we have to tell it to do it, which doesn't seem like a step forward in my mind. Anyway, we're getting distracted as usual. Let's get back on to doing some sound stuff. So, right, I've got. Let's connect to the audio. That's the first thing we need to do, is actually just connect up to the audio. So in the original sound PGEX, we do that by setting our block count and block sample zone. There's some other bits and pieces in there, but before we even get that far, let's just try and open the device and close the device cleanly. So this was the open device. It's waveout open for WinMM. We pass in a handle. We tell it we're mapping waves. We need to give it a wave format, so I guess we need to create this structure too. And then we pass in a function. Now, waveoutProc is the function that's called when the sound card needs some more data. But because of the nature of all of this, waveoutProc for me, did I do a wrapper function for this? I can't remember. No, I don't think I needed to do a wrapper because it was static anyway. Is here. So this is the function. So when the OS says, "Can you give me some more data?" I go away, and then all I did actually. Hang on, I need to look at this because I thought I was populating the data during here, and I'm not. I'm signaling a slave thread here to then go and do the data capture. Oh, it's interesting. Okay. All right. Oh, it's all starting to flood back now. Yeah, okay. And we're going to use exactly the same sort of strategy. We might tidy it up a bit with a slightly more modern conventions. Yeah, toneback is. I mean, it's const expression is a lot more flexible. Right? It can basically work with objects and all sorts of things. I mean, compilers have been able to work by determining simple types for years and years and years. But if you had sort of a very complex arrangement and hierarchy of object-oriented stuff, you wouldn't really be able to do that at compile time. But you can now with const expression. So where we want to do our audio open in our plugin, do I need to get sort of two windows? I think we're going to be sort of ping-ponging back and forth here. So I'm going to open up two windows. Oof. Two code windows. So on the left, I've got my new interface. And at the moment, all we're doing is creating this driver object. So something like initialize audio, what I want to have is an driver open. And that will go away and call whatever the driver object is that's been loaded up with the correct information. Now, this doesn't implement open. I don't even know if open is what I want to call it. I guess we need to start making some decisions, don't we? Well, I know that my implementation here is going to have a thread. Now, all of the audio implementation is going to have a thread. I think they do. So maybe we should add sort of a threading function as part of the base class for the audio driver. Let's do that. So where is my audio driver implementation? Here it is. Start, stop, close. So I think we want the thread here. So virtual void driver loop, we'll call that one. And do I want that to be abstract? I think, you see, this is what I'd rather we have the driver actually sort of launch its own thread and everything sensibly. There's no reason that the guys implementing their own audio driver will need to manually start these threads. We could actually handle that. and then inside this thread. Yeah, but okay. No, I'm going to keep it simple enough. The guys writing the audio backends will be able to cope, I think. So yes, I'm going to make that abstract for now. Let's pull in then some of these things. And where is my driver? Where am I writing? It's down here. So I've got my open function, start function, stop, close, and driver loop. Now, this is where I'm going to need some C++ aficionados, I think, because basically I want to thread this function, but this function isn't necessarily static, which could get a bit messy. See, in the original implementation, it is static, I think. Well, everything was static, yeah. So audio thread was. So this is the problem. Everything's all mixed in, and I wanted to avoid that. That's what we're really changing here. Mixed in. Where's my audio thread gone? Destroy audio. Sorry about proc. Where is the actual audio thread gone? I've lost it. Let's just have a look at this. Go to definite. Have you cut instead of copying it? Why does it take so long for lambdas to properly take off? Because they're messy. Where's my place? There's nothing there. Nothing there. Nothing there. Initialize. Audio sample stuff. Oh, audio thread. There it is. Yeah, it's just there. Just at the bottom of the list. Okay, so it's a static in the main interface, but now I want to shift that over to the driver, and I want it to be sort of implementable by the user. I guess it still could be static if the user is implementing it, right? Can you have? You can't have static virtuals. That makes sense, doesn't it? But they do have to provide an implementation, don't they? And that's going to be different per thing. So maybe I just don't need to bother making that virtual at all. Don't need that to be abstract. But when we get down to implementing the function, why are these red? Inherited member is not allowed. Huh? Or have I messed up the accesses here? Public driver loop. Function definition for driver loop not found. Oh, because this is the base class, right? Okay, so I think then this driver loop does need to be moved out of here and just directly into whatever the audio driver is doing. Okay, yeah, why not? That actually does make a bit of sense. So that just becomes in here. However we go about implementing that. Audio driver, WinMM, what's going on? These are inherited member is not allowed. I've not seen that error before. Open, yeah. How did I inherit my WinMM driver? Audio driver. WinMM public. Oh, it's because I've not actually defined that I'm overriding. Okay. Gone a bit too Java there, I think. We'll go to protected for these. Oh, we'll get rid of these implementations. And we'll get rid of these virtuals, and we'll bang in an override keyword in there just to keep things sane. There we are. Right. That's better. Hang on. Yeah. So, I think that's an okay solution, because let's say we have some obscure Linux audio platform, and maybe that's the case here, that doesn't actually do this with threads. It does some sort of bizarre hooks into the operating system. Maybe they don't actually want a loop. So I'm going to leave how you interact with the audio to the audio driver, which actually makes some design sense, right? Now you say it out loud, it's fairly obvious. It also does makes our implementation just a bit easier as well. Good. What is the auto format thing? In Visual Studio, I don't know. Usually, if I just do another thing, it'll do it automatically. But I'm sure there must be a keyboard shortcut for that. Hey, right. So in our open, this is where we want to start creating the connections to our audio driver. Regarding the strange promotion, it looks like a promotion is done in the multiplication, and the return type is actually larger. So Coloured Ice Creams on the Discord server has identified that, yeah, it is a promotion. In the multiply operator, but that's quite strange, because it shouldn't, even if the result got promoted, it would have to be truncated when it's converted to the integer format. The no point does the decimal place stuff exist, really. It is still stored as an integer, but of course to get 35 it has to be using more than 4 bits somewhere. Anyway, yeah, that's why I think it's an interesting little problem to solve. Right, I've lost my place in here now. Audio. Opening. I wish there was a way to set some custom sort of bookmark stuff in Visual Studio. Not just necessarily breakpoints, but actually sort of say, I just want to put a little flag here that can give me some sort of lockable cursor element. There. In line 1 to... Okay, that's in the fixed point stuff. I'll have a look at that in a minute. Right. I'm looking to open this audio device. We're going to do this, come rain or shine, we're going to do this today. Right, wave format we need for WMM. So this is told you it's going to be copy and paste fest, and we'll just start sort of refactoring as we need to go. So wave format X, these are all now very Windows specific things, because this is the Windows multimedia interface. And we have some additional variables to populate. So I've got in my audio driver base, I'm going to collapse this, because that's just getting in the way. And I'm going to collapse this, because we don't need those today. In my audio driver base class, I have sample rate, channels, blocks, and block samples, and some convenience utilities as well. So I think these are going to be ubiquitous across all of the driver implementations. You're always going to need to know that information. So that's why it can go into this common interface. You can open the bookmarks window and add bookmarks from there, but there's a hotkey for it as well. Yeah, I need to know what the hotkey is. I don't do additional windows. I don't even think I've got the bookmark stuff sort of set up anywhere. So what's this saying? Well, it's saying that we've got PCM format WAVs. Our sample rate is going to probably be about 44,100 bits per sample. This is I mean, this was somebody back in the day thinking you're going to use strange word sizes for samples. I don't think it probably ever happened. At least I'm not aware of any hardware which used odd numbers of samples, like 5-bit samples or anything like that. Number of channels is left, right, mono, stereo, 5.1, subwoofer stuff, all of that. It's an individual channel. Block align, I have no idea what block align actually does. But in the Microsoft Docs, it sort of suggests that you need to set it up this way. I'm guessing, again, that's probably a throwback to having something a bit more optimized when it's placed in memory. Average bytes per second. Yeah, again, I'm not entirely sure what that use is, other than arming the actual sound driver with perhaps some sort of timing information of how frequently it's expecting to blast one of these requests for a blockout. I mean, in this day and age, I suppose it doesn't really do anything. Right, so we've got our format set up, and these are going to be our device. So let's just go really simple. We've got our format. That's our device opening, and I just want to see if we've got our device closed. And we've got our thread there, so we need to launch our thread if necessary. So in the most basic sense, we've not set up any memory, not done anything. This is now audio WinMM driver loop instead of this. And we need some handles to our thread. So I'm going to change the names of these things as well. So to try and make things a little bit more consistent with naming. So this boolean would be an atomic, I'm guessing, in the original implementation. Yep, there it is. And I'm also going to steal this global time. Do I need to steal it? No, the driver doesn't care about global time. Audio thread and active thread. So these are unique to the WinMM implementation. These were... Did I set these up as static? Maybe. I don't need to do that though anymore. M thread driver loop and M B driver loop active. Right, so we also needed the actual handle to the Windows device. I think that's just handle. I have to get some documentation on the go, get it ready. Yeah, H wave out. Now, one of the changes I want to make this time around is I also want to do wave in, because that's really the whole point of this, is to start doing some audio processing. And wave in is almost identical to wave out in structure. So let's bang this up here. Nothing we can change really about that. Again, I don't think I need all of these things to be static. We'll worry about that sort of tidying up later on. So we can open our device, and there's our wave out proc function. So that is actually a bit more complicated. So let's just take that verbatim at the moment. Told you it's really just, for this particular driver, it's a cut and paste job. And once I'm happy with sort of the interface structure, then I will move things around a bit. Now, wave out proc, I'm not going to rename that, because that is the name used in every application that's ever used the Windows Multimedia Library. It's just one of those things. You don't ever need to change it. And the wave out proc function is, again, pretty much always the same, except I changed it a bit, didn't I? I said it uses a condition variable rather than actually being the thing that populates the audio. So I think we need to start to study these things just a little bit. Let's bring you in and put you down here. That's our driver loop and our wave out proc function. Ishidex getting involved with what's going on with the fixed point multiplication. The thing is, Ishi, is I just don't like the precedent that it sets, that it's obviously different behaviour when the compiler's working with it and at runtime. Yes, something. And what I'm expecting is presumably the community might actually get stuck into putting this on Godbolt and actually having a look at what's going on, comparing the different compilers, seeing whether they work or not. Right, so block 3 here is some variables. So these are the sort of the mechanics of the driver and how they work. If we don't have enough memory blocks available, everything gets suspended. It's got to kind of fail as gracefully as possible. It don't want it to just sort of crash and then throw an error at the user saying, well, you didn't give me enough sound samples. Instead, everything should just sort of nicely just stall, but only in sound land, not in user program land. Now the audio loop has changed a little bit as well. Because what I'd like is the audio loop, rather than to be responsible for doing the data transfer, I kind of want it to go and get the information it needs from the standardized interface, which is going to be this sound wave interface up here. Because this, in Pixel Game Engine land, everything's floats and everything's sort of in a nice common format. It's the drivers that care about things being different, which is not the case in the original implementation. If we don't open the device, what can we do? Well, probably just want to return false for the time being. Now, start is where I'd really like to start the thread. I want to sort of separate that control out. So let's do this as well. And we'll just assume it always works for now. What can go wrong? Just assuming it's always fine. And stop, we'll put in some guards and some joins later on. And close is sort of the opposite. It actually shuts down the hardware. Now, I'm a hardware engineer by trade. I'm actually always a bit fussy about shutting down hardware properly. I don't really need to in this. But only because I've had instances many times in the past where I've not shut down hardware and you can't boot it up again without having to power cycle the thing. So what I'm looking for is, how did I actually do that here? Did I actually do that here in the original version? I'm hoping that there's a destructor somewhere. Maybe I didn't. Audio thread. What's the audio thread doing? Nope. Destroy audio. Just joins the thread. I guess the thread became inactive. And it looks like I just let the thread expire there rather than actually doing anything with tidying up the others. This is why we need to address the audio library. It's just not... No, it did its job, but it's not exactly what I would say well engineered. Let's be honest, it's crap. That's why people haven't used it, even though it works. Yeah, it doesn't look like I actually do anything with the hardware. I just sort of go, yeah, have at it, and it runs out. There's not even a destructor. Brilliant. Right, so a bunch of variables to bring over. So number of free blocks, but these are driver-specific things. Find the WinMM driver again. X audio 2. If use X audio says that one. That doesn't look like the X audio stuff, does it? That's oh, if not def, then okay, that makes sense. And in here, there we go. Block 3 was for some reason again got all this sort of like weird threaded stuff going on, and I wonder if all of this is actually that necessary. So we need some memory to represent our blocks. Let's at least start there. Now, it's always very tempting to think, oh, why don't you use standard containers and things for this sort of stuff? Maybe we can, maybe we can't. We'll have to see how well that sort of thing plays with these implementations. So right now I know that if I've got a big block of memory with a pointer, that's fine. But it would be nicer to sort of allocate that in a slightly more modern way. Let's have a look, where do we actually do that allocation? Let's copy over some more of these variables first. We've got, that's you have our blocks, and each block has a header, but the same sort of deal. The headers are in a circular queue of headers. And the headers describe what's inside the audio block. Very driver-specific stuff. And I'm going to take those variables too. See, there's lots and lots of static going on here, and it worries me when I start seeing sort of static with threads. Usually there's a problem. Hef, thank you, Hef. Herbal Dance, hello. Some Baguettes agrees that, yeah. Right, let's look at where we're allocating this memory then. So it's, again, a bit of a scroll down here. So once we've opened the device, that's where we go and start allocating the memory. And you can see, if I bring the code in, and we'll probably just have time to look at this bit of code before we continue next time. But let's go back to our driver. As part of our initialize function, we open the device. If we successfully open the device, then we want to do some cool stuff. What is it that we want to do? Well, we want to allocate the total amount of memory for all of the blocks we've got in our system. So that's where this allocation occurs. Now, I could use perhaps a unique pointer or something like that to make sure that this is now accepted by the pedants and the zealots. And then I zero that memory. I don't know why. None of that's really even necessary, I suppose. It'll play some nice static or some interesting sounds when you start up otherwise. And then you do exactly the same with wave header. You want as many wave headers as you do number of blocks. So probably there's a scope there to tidy that up. Then link headers to block memory. I think this is why I ended up sticking with point. Oh dear. And this as well. So for each of the wave headers, you needed to give them sort of an index, yes, this long pointer to the data in the memory block. Now, that's all possible too. We can do that with access to the unique pointers data. But this here, this is actually a requirement. You might think, oh, here's Javid just bodging some horrible types together. And it's because the Win API realized, well, hang on, if we wanted like a pointer to char, well, obviously that's a long pointer to a string. So you pass audio data around in the Win API sort of audio subsystem as strings. Even though there's nothing to do with strings. This was way back before anybody cared about types. I'm coming from Clojure, and I'm utterly baffled how you can code this stuff without constant feedback from REPL. I started coding in Rust, and my workflow goes like this: small change, compile, small change, compile. No, I do like to compile quite frequently too. It's just that at the moment I'm at a point where there's nothing to compile. I guess there's also, you get to a point in life where you kind of take for granted that you know certain bits of your code are going to work. And I'm very comfortable using a debugger, so I have no problem running the code and then stepping through it and analysing it that way. Better keep the zealots calm, otherwise they may say angry emails. Well, I do get angry emails. I sound a bit under the weather. I am a little bit under the weather. For some reason, I've got quite a sore throat. I think what it is on Saturday I was field captain for my local archery club, and it was a special event, and so there was a lot of announcements and there was a lot of shooting, and it was a good day actually, but I wasn't expecting to be. And then on Sunday I was recording a video all day, and then on Monday I was in our factory floor all day, which involves quite a lot of shouting, so I seem to have just been messing around with my voice too much. I've posted in Discord about MSVC stuff if you care. Well, I do care. So the integer is actually being promoted, but then cast down immediately. Compiler does the right thing, is corrupted. So the constant expression, yeah, I think okay, standard in. You've come to kind of the conclusion I was expecting. It's just IntelliSense, IntelliSense trying to be too clever and making a mess of things. I might make a bit of a follow-up video then for that because I think it's an interesting one. Because I was absolutely certain that when I saw the comments, it popped up on my mobile phone, and I thought, do you know what? There's no way I've got that wrong. You know, I like to think I know what I'm doing a little bit, and so I took it at face value that actually what they'd observed was something strange because I remember the value 35, and I remember it being how am I representing 35 in 4 bits? So there's definitely something fishy there. Yeah, I think a follow-up might be in order for that. Right. So yes, believe it or not, they expect things to be passed around in string formats, whatever that mess is there. So I think these are all things that we'll attempt to tidy up, and I think we'll attempt to tidy these things up using more conventional means. I mean, there's nothing wrong with this. It does actually work quite well. And what have we got going on here? That's now the name of the thing, isn't it? That's this. There we go. Yeah, I don't think we're going to get to a point where we're going to hear anything today, unfortunately. Bit of a shame. No, I don't think so. So the conclusion, okay, we may as well finish this off with a bit of a conclusion here. If those late to the stream, I'll just repeat the phrase. The latest video that I put out was about fixed point numbers, and I got this fantastic comment from a fellow called I'm assuming a fellow called Thomas. Your circumference is 35, but in a 4.4-bit format. How is this possible? And the sort of my immediate assumption is that something's going wrong between constant expression evaluation in Visual Studio, and Standard Int here in the chat has confirmed, although it's on the Discord server in one of the chats there, that it's actually at runtime it does fail, which is what it's supposed to do, and it seems to be there is a discrepancy there. So Visual Studio is doing something nasty with constant expression. That might be worth talking to his Starfruit clone about that in the C++ chat, because he works with the Visual Studio compiler dev team, doesn't he? So it might be worth passing along to him. He might have an answer. Might say, yeah, we make that assumption. So it's just the IntelliSense, is it? Okay. Well, that's good to know. Right. Well, that seems like a natural stopping point for tonight. I think a bit of a shorter one than usual, but it's actually a bit later for me than usual tonight as well. And I can just hear a certain little somebody is getting a bit agitated by my voice because they're asleep in the room next door. With that, thank you all for watching. I will definitely, I think, follow up on the constant expression thing. We wrote some code today, or at least we copied and pasted some code, so that's an improvement. Yeah, Herbal does. I only do an hour, and then hopefully we'll do another hour next week. Too long didn't read. The compiler does the right thing in this case all the time. The IntelliSense does not. Well, that's that's good, and I'm going to use that as an example for all the people that only ever debug things via IntelliSense. Okay, right. Thank you very much, guys, and I'll see you later. Take care.